All right, let's talk about building AI agents that are truly autonomous. I mean, agents that don't just stop when they hit a wall, but actually keep going, relentlessly working towards their goal. Today, we're going to break down the blueprint for how to do just that.
So, you ever have this happen? You build an AI agent, it seems absolutely brilliant for a few turns, and then, poof, it just gives up. It hits a limit, runs into some little error, and just stops cold, waiting for you to come and fix it. And yet, we've all seen these demos, right? Agents like OpenClaw that seem to work tirelessly, like a little demon humming away in the background. What is their secret? How do they do that?
Well, what's really going on here, it all comes down to how we think about the agent in the first place. It's a really fundamental design choice, and it's what separates a kind of helpful assistant from a truly autonomous supervisor.
So think about it like this. On one side, you've got your interactive assistant. This is kind of like a really smart intern. They're fantastic when you're watching over their shoulder, but the second they get stuck, they stop everything and ask for help. But on the other side, you have the goal, the ideal, the autonomous supervisor. This is more like a senior manager. It just works relentlessly, retrying things, replanning on its own. It's like a background process that you can trust to get the job done.
Okay, so how do we build that supervisor? Well, if we look under the hood of systems like OpenClaw, we find that the secret, it isn't what you might think.
And here is the big secret, the real kicker. That relentless, never-stopping feeling you get from a really advanced agent? It does not come from some magical next-gen LLM that we don't have access to. Nope. It comes from the system that's built around the LLM. It's an engineering property. And you know what? That's fantastic news, because it means we can actually build it ourselves.
And that system has a name. It's called the orchestration layer. So what is it? Just think of it like this. It's the dedicated manager for your AI agent. The AI model is the talented worker, the one doing the thinking. But the orchestrator is this long-lived process that supervises it. It's the one that handles all the messy stuff, saving progress, retrying after a failure, managing tasks that take a long time. And it does all of this outside the model's limited context window.
So what's on this supervisor's to-do list all day? Well, first off, it automatically retries when the agent fails. It saves the entire session history to disk, so it never, ever loses its place. It proactively manages the AI's memory, figuring out what's important to keep. It also supervises those long background tasks so the agent isn't just sitting around waiting. It can even spin up little junior sub-agents to go do some research. And, crucially, it enforces the rules, like knowing when to finally say, okay, we've tried enough times, let's stop.
Now you might be thinking, okay, this sounds amazing, but do I really need to build a whole custom system like OpenClaw to get this? And the answer, thankfully, is no. We can actually build this using tools that a lot of us already have right at our fingertips.
And here is the best part. If you're working with a model like Claude, the Anthropic Agent SDK, it already gives you all the Lego bricks you need to build this entire system. Things like resuming a session, compacting the context, all these little hooks, they're all there, just waiting for us to put them together in the right way.
So what's the actual game plan here? Well, instead of trying to change the model itself, the most effective approach is to build a persistent orchestrator that literally wraps around the Agent SDK. You create your own supervisor process, and you use the SDK as its powerful engine.
All right, theory is great, but let's get into the how. How do we actually do this? Let's walk through the 3 core patterns for building a truly persistent agent, borrowing directly from the OpenClaw playbook. Okay, first and most important is what I call the never give up loop. Instead of just running your agent once, your orchestrator wraps the whole task in a big outer loop. So when the agent stops, say because it hit its maximum number of turns, your supervisor catches that specific error, it grabs the session ID, and it just tells the agent to continue right where it left off. Simple as that. It only truly gives up when it hits a global retry limit that you've set way up high. Next up, let's talk about memory. You know how this goes. As an agent works, its conversation history gets super long, and the SDK will automatically summarize the older parts to save space. Now that's generally a good thing, but it's like a student summarizing a textbook. Sometimes really key details can get lost in the summary. The solution is a really clever trick called a pre-compaction flush. The logic here is incredibly simple. Just like the quote says, before summarizing, write down what's important. In the SDK, there's a hook called pre-compact. Your orchestrator can use this hook to jump in right before that summarization happens. And when it does, it writes down all the crucial context, like key decisions the agent made or files it changed, to a separate durable ledger file on disk. That way, even after the history gets summarized, the agent never loses what we might call its task spine.
And finally,
What do you do about tasks that take forever, like running a build or a really complex test suite? You definitely don't want your expensive agent just sitting there twiddling its thumbs. The solution is to create custom tools for background tasks. So you could make a tool called execbg, for example. It would immediately return a process ID to the agent, which frees the agent up to think about other things. Meanwhile, your supervisor monitors that process in the background, and when it's finally done, the supervisor just pokes the agent and says, "Hey, the results are ready. Time to get back to work."
So let's just put this all side by side for a second. The baseline Claude agent, it ends on errors, but our persistent Claude, a supervisor loop just resumes it automatically. The baseline agent can lose context when it summarizes its history. Ours flushes that key memory to a durable ledger first. The baseline agent gets blocked by long tasks. Ours runs them in the background. You see the pattern here? This is the fundamental shift from a simple assistant to a truly autonomous supervisor.
So, as we kind of zoom out from the nitty-gritty details, it becomes really clear that this is about more than just some clever code. It's a fundamental shift in how we approach building these autonomous systems.
And honestly, this is the most important thing to take away from all this. That never-stopping feeling, that relentlessness, it isn't magic, and it's not some superpower you get by paying for a more expensive model. Persistence is an engineering discipline. It's about thoughtful architecture, supervisor processes, and state management. And that means it's a problem we as engineers can solve.
Which brings us to the final question, really. Now that you have the blueprint, now that you know the patterns for persistence, you can start to think way beyond just simple chatbots. So the real question is, what truly relentless, unstoppable agent are you going to build?